Welcome to dNAxt. We are discussing class A subnetting, and in this video we'll be discussing slash 13. Slash 13 signifies that there are 13 bits that are assigned to your networks or 13 bits are the network bits. For class A, slash 8 is the default CIDR value. So 8 bits are network bits for class A. But we have made them 13. So what we have done, we have borrowed 1, 2, 3, 4, 5 bits from host portion to make it slash 13. So these 5 bits which are highlighted in green are the subnetwork bits or subnet bits. These are the major network bits. So this is a major network portion, subnetwork portion, and these are the host bits in which third and fourth octet are purely host octet. First octet is a purely network octet and second octet is a combination of subnet bits and host bits. 5 bits out of 8, 5 bits are subnet bits and 3 bits are your host bits. So since we have 5 subnet bits, the subnetworks that we are going to get over here are 32. 2 to the power 5 is 32. So by borrowing 5 bits into the network, we are slicing up our network into 32 chunks. Okay, how many hosts per subnetwork we will get? We will get we get with the formula 2 to the power y minus 2. Why minus 2? Because in each subnetwork, the number of IP addresses that we will get, out of which one will be the network ID and one will be the broadcast ID, and these IP addresses we cannot assign to our host, and hence we subtract the number 2 to get actual accommodation of that particular subnetwork. This actually how many endpoints you can attach to that network that we can calculate by using this formula. So 2 to the power 19 is basically 5 lakh 24,288. 5,24,288 and minus 2 we will get 5,24,286. Actual these many endpoints you can attach in each subnetwork. Okay, what are the valid subnets? 256 minus subnet bit value. So first of all, let's calculate subnet bit value. Since we have 5 bits, first bit value is 128, second is 64, third is 32, fourth is 16, and fifth is 8. So that comes out as 248. So the subnet mask is 255.248.0.0. Now when we subtract the subnet bit value from 256, we get increment of 8. So basically what will be our network IDs or different subnetworks of the different subnetworks? That 10.0.0.0 increment of 8 in second octet, as we have borrowed the bits in second octet. So 10.8.0.0, 10.16.0.0, 10.24.0.0, 10.32.0.0, 10.40.0.0, 10.48.0.0. Okay, this will go on increment of 8. So 10.56.0.0, 10.64.0.0, 10.72.0.0, 10.80.0.0, 10.88.0.0. So total 32 subnetworks we will get. What will be the last subnetwork? 32nd subnetwork, that will be 10.256.0.0. 248.0.0. So the value in the second octet, by adding 888, last number I'll get 248. How do I calculate this? By simply writing this subnet bit value. यही वैल्यू आएगी आपके उस ऑक्टेट में जहां पे इंक्रीमेंट हो रहा है. Subnet bit value will be the value in the octet where increment is taking place. Because if you add 8 over here, it will become 256, which is not possible. So this is the last valid subnetwork in /13. Okay. What will be the broadcast ID of this? Simply 10.255.255.255. Okay. What will be the broadcast ID of this? 10.48 के बाद आता है 56. So 55.255.255. Here 10.47.255.255. Here 10.39.255.255. यहाँ पे 10.7.255.255. First valid host will be 10.0.0.1 and last valid host will be 10.7.255.254. Okay. Here first valid host will be 10.8.0.1 and the last valid host will be 10.15.255.254. This is your broadcast ID and 254 will be your last valid host. Over here, first valid host will be 10.48.0.1 and 10.55.255.254. Okay. Here first valid host will be 10.248.0.1 and the last valid host will be 10.255.255.254. So this is all about /13. We will be discussing /14 in the next video. So stay tuned with dNAxt. Till then, happy learning.